Hello everyone, welcome back in the next video in this series of linear algebra questions that are asked in the GATE examination in the previous year. So I hope you all are well. So let's start this video with first question. So now first question says given system of equation. Okay, we have two equation and we have three unknown x, y and z, and here the right hand side of equation are also unknown, which are called b1 and b2. Which one of the following is true regarding its solution? Okay, so we have a four option and we have to find out the one statement which is correct about this system of equation. So now let's look at the option A. Option A says the system will have infinitely many solutions for any given b1 and b2. So now they are saying about the solution. So now we have to first of all we have to represent this matrix, this set of equation into matrix form, like ax equal to b, and here this a is our coefficient matrix, b is our unknown variable vector, here x, y and z, and b is the right hand side of this equation in the form of a vector. So now from this notation we have to form the augmented matrix. So let's form augmented matrix directly here. So we have to put the coefficient matrix here. So coefficient of the first equation is 1, 2 and 2, and now for the second equation 5, 1 and 3. So now let put here this value b1 and b2 to make its augmented matrix. So now to find out the condition of solution for this system, we have to reduce this matrix into echelon form. So now I want to make this entry as 0. So now if I subtract this first row 5 times from this third row, in the second row, then I will end up here with 0. So let's write it here, r2 minus 5 times r1. It will give me a new r2. So now after that, what we are getting, let's put it here. So first row will remain as it is. Here b1 and b2 are unknown. So here 0, and now 2 multiply with minus 5. So 10 minus 10 plus 1. So I can say minus 9 here, and here minus 10 again plus 3. So I can say minus 7, and here b2 minus 5 times b1. So now look at the rank of this cofactor matrix here. This is nothing but our coefficient matrix, sorry, not cofactor, coefficient matrix. And now if we include this last column, then it is nothing but the augmented matrix. If we consider as whole matrix, then it will be an augmented matrix. So now I can say the rank of coefficient matrix here, rank of coefficient matrix here is 2, because it has two non-zero rows, this first row and the second row. In other words, I can say this first row and second row are linearly independent for this coefficient matrix. So I can say the rank of this 2 cross 3 matrix here is 2. And now the rank of augmented matrix, rank of augmented matrix, there is nothing again 2 here, because regardless of this value of this b1 and b2, if whatever here b1 and b2 may take any value from the real number, but now these two numbers are remain non-zero, because they have not any relation with this b1 and b2. So now again the rank of this augmented matrix is always 2. It not depend on this variable b1 and b2. So now I can say the rank of augmented matrix here is 2. And now the for the system have a solution, the necessary condition is that the rank of coefficient matrix and the rank of augmented matrix are equal, and here it is the case. The rank of coefficient matrix is 2 and the rank of augmented matrix is also 2. And now I can say the rank of this matrix is less than number of unknown. Here the number of unknown is 3. So I can say one variable is independent. In other words, I have to choose as random value for one variable. Let's suppose if I wanted to choose the random value for the variable z, then according that value I am getting the value of this x and y. So in that way I will end up with the infinitely many solution regardless of this b1 and b2, because whatever value this b1 and b2 may take, the rank of this augmented matrix is still 2, and it again less than number of unknown. Here the number of unknown is 3. So now I can say this system has infinitely many solutions regardless of this b1 and b2. So now the option say exactly in this way. So option A says the system will have infinitely many solutions for any given b1 and b2. So yes, it is the correct one, because we have find out the rank of this coefficient matrix and augmented matrix in which is less than number of unknown. So at least one variable is independent. So the system has infinitely many solutions. Let's also go through this remaining option. Option B says the system has unique solution for any given b1 and b2. Now here it is not the case, because whenever the system has a unique solution, the rank of coefficient matrix and augmented matrix are exactly equal to the number of unknown. But now here the rank is one less, on the other one the matrix is rank deficient. So again the option B is not the correct one. Now let's move to the C. Option C says whether or not a solution exists depend on the given b1 and b2. Now again here the system is always consistent, because the rank of coefficient matrix and the rank of augmented matrix is always equal, because this b1 and b2 not affecting the rank of this augmented matrix due to this two constant term here. So now again option C is also wrong one. Option D says the system would have no solution for any values of b1 and b2. Again it is not the case. If this is the case, then the rank of coefficient matrix and the rank of augmented matrix are not equal, non-equal. They have non-equal values, but here they have equal rank, and which is 2. So option D is also wrong. So only option C is the correct statement from this four statement. Now let's move to the next question. Okay, now let's solve question number 2. Question 2 says a straight line of form y equal mx plus c. It is nothing but thus simple straight line with slope m and y intercept c. So now passes through the origin and the point x comma y. The value of x and y here 2 comma 6. The value of m. Okay, they're asking about the value of this slope m here. So now this equation y equal to mx plus c is simply a straight line with slope m and some intersect in with y axis, which is c here. So now in the general way, if I wanted to draw this line, so let's assume this c has any positive value. So in this xy plane here, x and y, I am getting the straight line like this with some positive slope. Also I have assumed the value of m and x here both are positive. So now this line is nothing but simple mx plus c. So now here in the question it is given that the this line must pass through the origin from this point is nothing but the origin, and this point 2 comma 6. So somewhere here, like you can put it here. So now what you have to do is just simply slide this line parallel to this line with in such way this resultant line will pass through the origin and this 2 comma 6 point like this. So now it is our new line. Simply we have to put the these 2 point in this equation, and we end up with our answer. Here the second point is nothing but 2 comma 6. So let use this first point. Let put both x and y as 0. So the left hand side will 0 here, m multiplied with 0 again will be 0 and plus c. So I can say the value of c here is nothing but 0. So we have find out the value of c. So now our equation will become like y equal to simple mx, because the c has value here 0. Now use this second point, put as y equal to 6, m times x equal to 2. So I can say the value of m here is 3, and which is the slope of this line. So I can say the slope of this line is nothing but 3, and here the slope is represented by this m. So they are asking about the value of this m, so it is 3. Okay, now let's solve question 3. Question 3 says consider a matrix. Okay, we have a matrix A, and which is a 3 cross 3 matrix. whose eigenvalues are 1, -1 and 3. Sorry, yeah, plus 3. The trace of a cube minus 3a square is what? Okay, so they are asking about the trace of this matrix. So let's put it here. They are asking about the trace of this a cube minus 3a square. So now one may can solve this problem with conventional method, finding the cube of this matrix. And to find this cube, you have to first of all square it this matrix, and again you have to multiply itself with to find the cube. So now after that you have to do some algebraic addition and subtraction to find this matrix, resultant matrix, and after that you have to just sum the diagonal element. But it is very lengthy process and also time consuming. But now here the shortcut way is that use the concept of eigenvalue, because the eigenvalue of this matrix a is given here in the question. So now we have to just we have to use the concept of eigenvalue here. The trace of any matrix is nothing but the sum of all eigenvalue. So let's assume it has eigenvalue as lambda 1 plus lambda 2 plus lambda 3, because it is a 3 cross 3 matrix here. So this matrix is also 3 cross 3. So it has 3 eigenvalues. So now the value of this lambda 1, lambda 2 and lambda 3 are unknown for us. So first of all we have to find the value of these 3 unknown. So now to do this task we have to take the help of this eigenvalue which are corresponding to this matrix A. So now let's call it beta 1 here for beta 2 and beta 3 to distinguish from this. So now eigenvalue, let's put it here. A cube minus 3a square. So now let's find first of all lambda 1. So here use this beta 1 and just replace this a with this beta 1 value. Now it is the property for the eigenvalue. If this beta 1 is corresponding to the a, then the eigenvalue of resultant matrix here in this case is nothing but thus we have to replace this matrix a with the eigenvalue of the initial matrix here a. So after that we are end up with the eigenvalue of this whole matrix. So now we are calling it lambda 1. So use this 1 here, put it here. So 1 cube, again 1 minus 3. So I can say minus 2 is my first eigenvalue. Now let's find the second eigenvalue for this matrix again. So now let's use this minus 1. So put it here. So again minus 1 minus 3. So I can say minus 4. It will be my second eigenvalue for this matrix. And the last one lambda 3, let's use this 3 and put it here. So 3 cube 27 minus here again 27. So third eigenvalue will be 0 for this matrix. So we have find out the 3 eigenvalues for this matrix here, and we have to find the trace of this matrix. So simply we have to add those 3 numbers. So I can say the addition of those 3 numbers is nothing but simply minus 6, and which is the trace of this matrix here. So I can write here as minus 6 as my answer. Okay, now let's move to the next question. Okay, now let's solve question 4. Question 4 says consider the following system of linear equations. Okay, we have two equations and we have two unknown x and y, and those two equations are non-homogeneous because the right hand side is non-zero here. Here x and y are unknowns and k is real constant here. The coefficient k here and also in the second equation is any real constant. The value of k for which there are infinite number of solutions. Okay, so they are asking about the value of this k which is any real constant in such a way that the system has infinitely many solutions. So now first of all let's form the augmented matrix. Augmented matrix. So now we have to put the coefficient matrix here which has value as 3 and 2k, and here k 6, and we have to put the right hand side here to make it augmented matrix. So now we have make the augmented matrix. So now to we have to reduce this matrix into echelon form. So now we have to perform some row operation. So now I wanted to make this entry as 0. So now if I divide this first row with 3 and multiply with negative k and add in this second row, then this entry will be 0, and it is our aim to reduce, to make this matrix as in the echelon form. So let's write it here. What we are going to do, we are subtracting this first row with this multiplication. It will bring me new r2. So now after that, what we are getting, let's write it here. The first row will remain as it is, 3 2k and minus k. Here the entry will be 0 because here this factor will be multiplied with this minus k by 3, and now here 6 minus, I can say, 2k square by 3, and here 2 plus 2k by 3, because this negative 2 multiplied with this factor minus k by 3, so it will be plus 2k by 3. Now matrix is over. So now if the system has infinitely many solutions, then again the same concept, the rank of this matrix must be deficient. It cannot have a full rank. Then it will have infinitely many solutions. So this matrix must have a rank less than 2. So now if you see, if this entry and this entry will both simultaneously will 0, then this matrix has one row as non-zero and this second row is all as 0 0. So we can say the rank of coefficient matrix and the rank of augmented matrix will be equal, and which is less than 2, and here the 2 is number of unknown. So I can say this matrix must have rank as 1. So now to make this matrix in such a way that the rank of matrix is 1, we have to make this second row as all entries as 0. So now let's equate this term with 0. So I can say 2 plus 2k by 3 equal to 0. So one can say the value of k is nothing but minus 3 here from this equation. So now if k is minus 3, then let's put the value of k of minus 3 here. If this equation has, if this quantity is also 0, then the system has infinitely many solution for this value of k. So let's put it here. 6 minus 2 minus 3 square by 3, and yes, you can see 6 here. This minus 3 square will be 9, so 1 3 will cancel, so again 6, and yes, it is also give me 0. So now if we select, if k is minus 3, then our resultant augmented matrix here looks like this. Here minus 6 minus 2 0 0 and 0. So now you can say the rank of this matrix here, both as a coefficient matrix and augmented matrix, are equal. Rank of augmented matrix is exactly same as rank of coefficient matrix, and which is 1, which is again less than number of unknown. Number of unknown here is 2, x and y. So now I can say the system has infinitely many solutions if the real constant k take the value of negative 3. So option A contain the correct choice for this real constant k here. So now let's move to the question number 5. Okay, now let's solve question 5. Question 5 says the diagonal element of 3 cross 3 matrix are minus 10, 5 and 0 respectively if two of its eigenvalues are negative 15 each. The third eigenvalue is what? Okay, so they're asking about the third eigenvalue. We have given the eigenvalue for the two eigenvalues, and which is minus 50. So now we have to simply use the property. This question is very simple. The trace of any matrix is nothing but the sum of its all eigenvalue. Here the matrix is 3 cross 3, so it has 3 eigenvalues. So I can put like this. Here the trace is nothing but the sum of all diagonal elements, and here the diagonal elements are given for this 3 cross 3 matrix. So the trace here is nothing but the sum of those four numbers. Here the sum will be minus 5, because minus 10 plus 5 plus 0, it will give me negative 5. So now here the value of this lambda 1 and lambda 2 is given minus 50 each. So I can say minus 15 plus lambda 3 which is unknown, and value of this lambda t we have to find out. So now I can say minus 5 equal to minus 30 plus lambda 3. So I can say the value of lambda 3 here is 25. So we have find out the third eigenvalue, and which is 25 with the help of this property. So now it is very simple question. It's only take few seconds to solve. Now let's move to the question number 6. Okay, let's solve question number 6. Question 6 says consider non-singular 2 cross 2 square matrix A. Trace of A is 4 and the trace of A square is 5. The determinant of matrix A. Okay, so they're asking about the determinant and we have given some value. We do not know any entries of this matrix A here, but it is given that the matrix A is 2 cross 2 and non-singular. Now recall the definition of non-singular. If any matrix has determinant as non-zero, then we are calling the matrix is non-singular. And if the determinant is 0, then we are calling it a singular matrix. So now here we have to use the same property that we did in the previous question. Simply trace of any matrix. Here the matrix is A is nothing but the sum of its all eigenvalue, and here the matrix is 2 cross 2, so it has two eigenvalues, and here lambda 1 and lambda 2. We do not know the here the value of lambda 1 and lambda 2, and we have to find out these two unknown. So to find out these two unknown, we must need two equations. So now they have given the detail about the trace of matrix A and trace of A square. Here let's put it here, trace of matrix A square. Now if A has eigenvalue as lambda 1 and lambda 2, then A square has eigenvalue as lambda 1 square plus lambda 2 square. Simply the eigenvalue is also square due to here we have, because we have here square the matrix, so the same operation is apply on the eigenvalue. So now we have two equation and two unknown. Here let's put it here, the sum of this lambda 1 and lambda 2 is 4 because the trace of A is 4, and the sum of lambda 1 square plus lambda 2 square equal to 5. Now we have two equation and two unknown, so we have to solve these two equation. From this we can get the value of lambda 1 and lambda 2, and from this we can easily find the determinant, because the determinant of any matrix is nothing but the multiplication of all its eigenvalue lambda 1 and lambda 2. So now the determinant it must be non-zero because it is given that the matrix is non-singular. So now to solve this equation, you can solve algebraically because here, but you have to at the end you end up with the quadratic equation and you have to find the root of this quadratic equation. But now the easier process is that if I square the first equation both the side, then I will get like this, lambda 1 plus lambda 2 whole square equal to 16. So now if I expand this bracket, then what I am getting, let's put it here, lambda 1 square plus lambda 2 square plus 2 times lambda 1 lambda 2 equal to 16. So now here the value of this lambda 1 square plus lambda 2 square is already we have, and it is 5. So let's put it here, and here the multiplication of this lambda 1 and lambda 2 is nothing but our determinant. So let's replace it with this determinant sign, and equal we have 16. So now we can say 2 times the determinant will be equal to the 11. So one can say the value of determinant here is nothing but 5.5. So now we can easily say the determinant of matrix A here is 5.5, and they are asking about the one decimal place. So our answer is correct in this way. So now let's move to the next question. Okay, now let's solve question 7. Question 7 says let A, again we have matrix A, and which is 3 cross 3 matrix, and matrix B. Okay, and we have uh, B has some particular relation with this matrix A in this some polynomial form, where where I is 3 cross 3 identity matrix, the determinant of B is what? Okay, so they are asking about the value of determinant for this unknown matrix B here. So simply we have to use the concept of eigenvalue to find the determinant of this matrix B. So I can say the determinant of this matrix B is nothing but the multiplication of its all eigenvalues. So let put here lambda 1 times lambda 2 times lambda 3. Let's make it prime to lambda 1 dash plus lambda 2 dash and multiply with lambda 3 dash to distinguish from this eigenvalue of this matrix A. So now we do not know the value of this three unknown. To find out the value of this lambda 1 dash and lambda 2 dash and lambda 3 dash, we have to first of all find the value of this matrix A, and simply we have to put those eigenvalues here in this equation to get the eigenvalue of this eigenvalue for this matrix B. So now first of all let's form the characteristic equation for this matrix A. So A minus lambda I have to find the determinant of this quantity and is equal to 0. So let write it here 1 minus lambda 0 minus 1 minus 1 2 minus lambda 0 0 0 and minus 2 minus lambda, and we have to find the determinant and equate equal to 0 to find the characteristic equation. From this equation we can easily find the value of this lambda here. So I can say determinant of this matrix is nothing but like this multiplication of these three, and here the second element will be 0 because the entry here is 0, and in same way the third entry here is also 0 because the minor of determinant of this minor is also 0. So we can equate this equation equal to 0. So now simply one can say here that the three eigenvalues for this matrix A has value as 1 lambda 2 equal to plus 2 from this bracket, take a second bracket, and lambda 3 is minus 2 from this last bracket. So now we have find out the eigenvalues for matrix A here, but we need the eigenvalue for matrix B, and B has some particular relationship with A, and B is described as A cube minus A square minus 4A plus 5I. So now remember the property of eigenvalue. To find the eigenvalue of B, whatever the operation is performing on the matrix A is same perform on the this eigenvalue to get the eigenvalue of this matrix B. So now let's use this first lambda 1 and let's the eigenvalues values for matrix B here. Let's call lambda 1 dash here. So now let's select this lambda 1 first. So replace this A with 1 here. So I can write here 1 cube minus 1 square minus 4 times 1 plus 5. Now here we have identity matrix, and all order of identity matrix has eigenvalue as 1. So we can also replace this I with 1. So now let's simplify it. So this one will cancel. So 5 minus 1, it will give me plus 1. So the first eigenvalue for this matrix B is 1. So now also let's find the second eigenvalue lambda 2 dash. Again let's put the 2 here at the place of matrix A in this equation. So I can say 2 cube minus 2 square minus 4 times 2 plus again here 5 times 1 because here we have to replace this identity matrix with 1 because it has eigenvalue as 1. So now again here 8, so this 8 will cancel with this 8, and again here 4. So 5 minus 4, again we are getting plus 1. So now let's find the third eigenvalue for this matrix B, and which is lambda 1 dash. So now let's use this negative 2 because it is only the remaining entry. Let's replace this A with this negative 2 here in this equation because B has relation with A in this way. So I can write like this minus 2 square, sorry not plus, minus 4 times minus 2 plus 5 times 1, and let's simplify it. So here minus 8 minus 4 plus 8 plus 5. Again one can say this and this will cancel out, and again we are getting the eigenvalue as 1. So the three eigenvalues for this matrix B has value as 1 as first eigenvalue, 1 as second eigenvalue, and 1 as third eigenvalue. So now we have to find the determinant. So simply we have to multiply it. We have to multiply these three eigenvalues. So I can say the determinant of matrix B is nothing but the multiplication of those three number here. So now let's multiply those three, and yes, the multiplication is 1. So again the determinant is 1 for this matrix B. So we have to put simply 1 here. Now let's move to the our next question. Okay, now let's solve question 8. Question 8 says consider a matrix P. Here again the P is 3 cross 3 matrix. The number of distinct eigenvalue of P is, okay, so they're asking about the number of distinct eigenvalue. So now one may can recall here this matrix P is nothing but the upper triangular, because the all the entries below the diagonal are 0. Here this all three entries are 0. So one can say this matrix is nothing but the upper triangular. So we have to find the characteristic equation to get the eigenvalue. So one can say here 1 minus lambda. The matrix P here is upper triangular, so the eigenvalue of any upper triangle or lower triangle matrix is nothing but the all entries diagonal. Here of all entries of this diagonal is nothing but the eigenvalue for any triangular matrix. And now we have to equate this determinant equal to 0. So one can find the determinant as 1 minus lambda 1, 1 minus lambda 1, and all the remaining minors of this second order will be 0, and we have to equate equal to 0. So one can say lambda 1 is 1 from this first bracket, and the lambda 2 is again 1 from the second bracket, and this lambda 3 is again 1 from this third bracket. So now we have find out the three eigenvalues, and which is nothing but the this diagonal element, this one and this one, because this matrix P here is the triangular matrix. So triangular matrix has property its eigenvalues are nothing but its diagonal entries. So now they are asking about the number of distinct eigenvalues. So we are getting the three eigenvalue, but they are repeating here 1, 1 and 1. So the number of distinct eigenvalue is only 1, because only the 1 which is repeating. So only the one entry we can say it is a distinct. So option C is the correct one, because here the eigenvalue is repeating. Now let's solve question 9. Question 9 says in a matrix equation Ax equal to R. Here the matrix A is given. Again the A is 3 cross 3 matrix. Vector X is also given, and the right hand side R, sorry here not Y but vector R is also given. So now they are asking about the one of the eigenvalue of this matrix A here. So the same concept we have to use here. Ax equal to lambda x, that we have used, that we used so many times in our this series. So now we have given a matrix A. So let's put it here. It has value 4, 8, 4, 8, 16, minus 4, 4, minus 4, plus 15. And now we have to multiply this matrix with vector here x, which has value as 2, 1 and 4. Now if we multiply, then we get the right hand side R, and the R is also given in the question. So let's put the R also here, which has entry as 32, 60, 64. You can also check by the multiplication of this matrix with this column vector. So now if you if let's check for this first element 32. So here this 4 will multiply with this 2, so 8 plus 16, and 16 plus 16 is 32. In the same way you can also get the 16 here for the second entry and 64 for this third entry. So now again we have to represent this vector in this lambda time initial vector. So now let's here again assume the any scalar lambda and which is the eigenvalue, and now let's put this vector 2 1 4 as it is, because if this is going to happen, then and then we can say the matrix has eigenvalue as lambda here, this scalar. So now let's equate this 32 with 2 lambda. So I can say 32 equal to 2 lambda. So the value of lambda here is 16. So now we can say the one of the eigenvalue for this matrix A here is nothing but 16. So the option D is the correct answer for this question. Now let's solve last question for this video. The question 10 says the set of equation. Okay, again we have three equation, and again those three equation are non-zero because the non-homogeneous because the right hand side is non-zero, and we have three unknown x, y, and z, and we have also some constant a here. So they're asking the if the system had infinitely solution, then the value of a is what? Okay, here if system has infinite solution, if a is what? Okay, so let's first of all form the augmented matrix. Simply we have to put the coefficient matrix here, 1 1 1 for the from the first equation, and a minus a plus 3 from this second equation, and plus 5 minus 3 plus a from this last equation, and we have to put the right hand side here to make it augmented matrix 1 plus 5 6 in the same order. So now to reduce this matrix into echelon form, we have to perform some row operation. So now let to make this matrix as an echelon matrix, we have to make this element and this element and this element are 0. So first of all let make this a and plus 5 as 0. So I can write like this: if I'm subtracting this first row a times from this second row, so then this element will be 0. So I can say a times r1, it will give me new r2. And now in the same way, if I subtract the 5 times the first row from this third row, then this entry is also 0. So I can say it will give me new r3. So now after these two operation, what we are getting, let's put it here: this first row will remain as it is. Here also, here we are getting 0, here we are getting minus 2a, and here 3 minus a, 3 minus a, and here 5 minus a, because we have multiplied this first row with negative a. So now in the third row, here we are getting 0, here 5 minus 5 minus 8 minus minus 3, so minus 8, here a minus 5, and here 6 minus 5 will bring me 1. So now if the system has infinitely many solutions, then this matrix is must be rank deficient. Then and then the system has infinitely many solutions. In the other way, either the this equation has a rank as 1 or 2, and it must be less than the number of unknown. Here the number of unknown is 3. So I can say the rank of coefficient matrix A is exactly same as the rank of augmented matrix, and which is definitely less than the number of unknown. Here the number of unknown is 3. We have 3 unknown x, y, and z. So now if the system has rank as 2, then one of its row must have all entries have 0. So now if you look the careful here in the matrix, so now what we have to do in the next step, we have to use this option to reach our final answer, because if we further proceed to simplify this equation and making the rank as 2, it's take more time, because here there are many elements which contain this unknown a. So the simplifying further this matrix is little bit difficult. So let's use this first option a. Option a contain the value of a is negative 3. So let's put it here. So here minus 2 multiply with negative 3, so it will be plus 6. Here 3, sorry, again plus 6, and here 3 5 plus 3, so 8. So now if you do for this option a, b, and c, then you cannot reduce this matrix as into the second order matrix, second rank matrix. So now, but look at the option D. If you put the value of A here is 4, then here we are getting minus 8. Here 3 minus 4, so minus 1, and also we have to put the 4 here because we also have constant A here. So 4 minus 1, sorry, 4 minus 5, again minus 1. Here we also have minus 1, and here 5 minus 4, again 1. So now you can see this second row and third row will exactly identical for the value of A as 4. So let put the value of A is nothing but 4. So now our resultant, this augmented matrix, will look like this: 1 1 1, and here this entry is 1. Here 0 minus 8 minus 1 plus 1, 0 minus 8 minus 1, and here plus 1. So now you can see this second row and this third row is exactly identical. So I can say row 2 is exactly same as row 3. So I can further reduce this matrix with some extra row operation. Simply we have to subtract this second row from this third row. So we can make this all entries as 0 after this, after that operation. So now we can say the rank of here the matrix is 2, and which is exactly, sorry, which is less than the number of unknown. So our system has equation and infinitely many solutions. So the correct value for this constant A here is 4, and option D is the correct answer for this question. And thanks for watching this video. See you later on the next video. Bye bye.